the last speaker for this morning. I have the pleasure to introduce you Yossi Daya, who are a senior security researcher at Akamai. And Yossi will speak about web boats. So it seems quite promising presentation. So Yossi, the floor is yours.
Thank you very much. Hello, I am Yossi Daya. I'm a senior security researcher at Akamai Technologies. We sit in Israel. And I'm here today to talk with you about the phenomena of web robots. As you know, there are crawlers, spiders, scrapers going over the web. And it's a very wide phenomena as illustrated by this dramatic title and the scene from iRobot. In the last year, we at Akamai, we led research in this field of web robots. And now I want to present you some of our research, a little bit of statistics, examples, detection methods or mitigation methods towards all this robot phenomena. So first of all, I want to start with a question that we hear now and then from our clients at Akamai. Why is my site so popular suddenly? A client detects certain spike in his traffic to maybe a certain feature in his application, and he wants to know why the reason. So I'm going to show you a real life story, a true story that happened a few weeks ago even. Okay, one of our clients who is a large retail, and he have a website, he detects traffic increase. He tried to do a little bit of basis analysis to his traffic to detect what is he seeing, what's happening. He says the increase is not related with a small set of IPs. So he tries to make a decision. He rules out DDoS because it's not very aggressive, it's not something that dropping his service. It's a spike, but it's not something that is dropping his service, it's not a DDoS. He also says it doesn't seem like a scraper because it seems like they are using real browsers and they are not, each IP doesn't seem like doing a scraping activity. It's also not an attack. It's not a malicious traffic. It's nothing malicious out there. It's just traffic, regular traffic, but it increases. What it does see is it's thousands of new IPs. Each IP browses for products. This website have a catalog of products, and each one of these IPs is browses for products. And each one of these IPs creates a small number of requests. Nothing that seems very, very aggressive from each IP. So the client says, it doesn't seem like a DDoS. I don't think it's a scraper. It's definitely not a web attack. What is it then? This is where we're going, and we did a little bit of analysis on this traffic. We have a big data, so we try to do some behavioral profiling on this activity and to see if we're detecting something, and we can say what we are detecting. First of all, we detected that in this time span, 3,000 IPs coming from only 15 different subnets. IPs from the whole subnet were used. And they all went to this website. Each IP only requested a little bit less than 100 requests, HTTP requests. But all IPs we detected belongs to the same cloud provider. So, okay, this seems a little bit suspicious. What we also know, find out that all IPs requested the same folder, but changed the file name. Which in this example, it's actually the folder is the product and the file name is the product's ID. We try to detect signatures of this activity. We detected that all of those IPs and with all of those requests used a single user agent, which by looking at the user agent, it seems like a regular user agent of a Firefox, not very up-to-date Firefox version, but still exists. People work with this Firefox version. We also detected another weird thing. All these HTTP requests had a common header names. First of all, connection close, which is weird because a browser will usually use connection keep alive. Also X forwarded for unknown, which means, okay, it comes from a proxy that hides the source IP. It's a little bit weird, but doesn't say anything about the whole phenomena, only about this certain request or this certain IP. Detecting all of those stuff, all those behaviors and signatures, we came to a conclusion that it is not only a scraper, okay? It's a highly distributed mega scraper. First of all, if we look at the mega scraper as a botnet, we detected that it was generating millions of HTTP requests, while each IP only created less than 100, but all the botnet was millions of HTTP requests. We did some further research on the botnet, and we discovered that he also scraped and attacked 7 other different large retail websites using the same method. So only by looking at it as a wide phenomena, we can see the big picture, because if we would look at it as an IP, we won't see anything, because none of the IP will go under our radar. None of them will be detected as malicious, or I don't know, maybe there's something weird about them, but nothing that we can put our finger on. Only by looking at it as at the broad look, and we detect this botnet, we detect all those IPs coming from specific subnets, all belong to the same network, all going to the same resource, all browsing for product IDs, and together with all that, all of them are using the same exact signature. So that's how we can say, okay, this is a mega scraper. This is a botnet, a very big botnet, and this is the way to detect it. We converged all of this data to one single scraper. Okay, let me a little bit tell you something about our big data. Okay, we at Akamai, we have a lot of clients. We see up to 30% of our websites going to our servers. So based on all this data we see in our servers, we built our own big data platform, which we call the Cloud Security Intelligence. It says here we have 20 terabytes of daily attack data, but we also have a lot of feeds of not only attack data, regular data, aggregated fields to detect behaviors. Okay, we have 2 petabytes of security data stored. It's up to 90 days of retention. It's indexed. We have a lot of queries that are running daily. Okay, so based on this big data and what we see on this big data, we try to ask ourselves a question: how many bots are we seeing out there? So we took a one-day traffic, 24 hours last month, and did a little bit of analysis on it based on all our detection methods. So what we discovered that in one day, we see that out of 85 billion requests that we see one day going through our servers, 8 billion of them was bot traffic. Okay, this is almost 9.5% of all traffic is bot traffic. This is what we see. This is what we detect. We try to analyze this traffic, see if we can categorize all those bots to say if we can say something about them. Okay, first of all, we detected that 26% of all bots are search engines and site indexers. You have your big search engines, you know them, Google, Bing, but there are also a lot of esoteric search engines, specific search engines. All those search engines crawl the web, go through all the web, so it makes a lot of noise. So that's why 26% of all bot traffic is of search engines. 43% is crawlers, spiders, and scrapers. Let's zoom in on that. 24% of them are content scrapers. Those are scrapers, bots that go to your website and scrape data. We don't know what the purpose, we just know they scrape data from your website. 7% are advertising tools. Those are tools that crawl your data and collect data from your website for advertising purposes. We have data aggregators, bots that go to multiple data sources, multiple websites, collect data from there and aggregate it in a one page, like RSS readers. We have web archivers, a lot of bots out there that archive the web. We don't know what the purpose, but they archive the web, maybe for academic purposes. A lot of website monitors that check for broken links, performance. SEO analyzers that go to your website and for optimization purposes. Even social media crawlers, a lot of them we see go to social media websites, crawl for data from there. I don't know, it's used for people finder or maybe for trend analysis or semantic analysis and things like that. Okay, those are the crawls and spiders. We also have 6% of all bot traffic is API engines, which are API clients, go to public APIs, RESTful services, web services, a lot of those. 1% are security scanners that go to scan for vulnerabilities in applications. 1% of all traffic, of all bot traffic. 24% is other bots. We detect that those are bots. This is bot traffic, but we can't really say what they are doing, what their purposes, what's standing behind them. So we categorize them as other bots. Our main goal is to lower this number down, maybe add some more categories or expand existing categories. But this is the picture as we see right now. So, what are our common bot challenges? Why a bot is bad? A crawler, why is he bad? First of all, stolen intellectual property. A scraper or a bot or a crawler comes to your website, steals data from there. We don't know what he does with it. Okay, it's your intellectual property. Increased price competition. We see a lot of competitors crawl each other's sites and scrape prices for the purpose of competition, to check what is the price of their competitors so they can lower down the price or do some kind of balancing. Additional bandwidth costs, okay, it goes without saying, a lot of bandwidth. If you have a CDN company, you are a client of a CDN company, you will pay a lot more for all those additional bandwidth. So after giving you some statistics and example, I want to review our bot detection approaches. We have several approaches for detecting bots. As you can see, my character is played by Will Smith, which is cool. We have certain approaches. First of all, the transactional based. We can detect a bot based on single HTTP request. He has a signature in his request. Maybe it's in a user agent or it's in the request header. We have the behavioral approach, like we saw the first example. We go on a traffic of a website and we try to detect if we are seeing a bot an activity that is profiled as bot activity. Try to differentiate between the human browsers, the human users, and the bot users. So it's a big data analytics and it's observation over time. You have rate controls, okay? If someone exceeds the rate controls, then he's probably a bot. He can be even a DDoS attack, but he's a bot, he's not human. Human versus bot challenges. We can place a challenge for the bot. The simplest challenge is to see if he obtains JavaScript. A browser will obtain JavaScript, but a normal HTTP library won't obtain JavaScript. You can give him CAPTCHAs. You can even give him some honeypots there, see if he goes to the honeypots. Those are the human versus bot challenges that exist. I want to expand now on our first two detection methods and a little bit expand about them. Signatures. Based on one transaction, how can we detect a bot? Actually, the approach to a signature-based detection, we kind of ask some questions for the bot. We kind of a Turing test to detect if it's a bot or a human. First of all, we ask, who are you? There are a lot of declared bots out there, bots that they say, okay, I am this and this bot, this is my name, here's what I do, here's my homepage, and this is my contact info. Mostly they declare themselves, identify themselves on the user agent string, but also sometimes in the HTTP request header. So you have a header name from or a header name xcrawler. I have a lot of header names that are used by bots. This is an example of a user agent structure of a declared bot. He specifies his name, his version, and his URL. He can add there a description and all the things I mentioned earlier. This is who are you? Second question we can ask is, what platform are you using? Okay, a lot of bots use certain platforms to do the bot activity. not with the browsers. So we have those are the detected bots. We detect them based on user agent signature or even HTTP request header signatures, like header ordering, number of headers they are using. You have development platforms that this is a platform used by bots like Java, Python, Ruby, what have you. You have HTTP libraries. All of those platforms have a built-in HTTP library, libraries that manage HTTP requests and responses. You also have a lot of scraping platforms, libraries and services. You have libraries built in Python or Ruby that actually manage scraping activity. They manage requests and responses. They parse your HTML. You can manage your crawling or scraping workflow. You also have services, scraping as a service. There's a service that you can go to the service. You can determine what kind of what website do you want to scrape. You can determine the fields, and he will build a script for you that will automatically run from his server and do this activity. Also, those can be detected by user agent or by HTTP header. You have a lot of headless browser automation tools that can also be used for bot activity, like Phantom.js, Selenium, WebInject. There are a lot of those that imitate human activity, and you can automate it. So those are also can be detected by signature. Another good signature is to see where is this bot coming from. Okay. We detected that bots prefer to use certain type of networks or gateways to the internet with their activity. So to know the source is a good indication. Proxy servers, a lot of bots go through proxy, do all the activity through proxy servers. VPS, similar to proxy, they open a VPN tunnel and go through this to the web and do their scraping activity. Tor, of course, this is used for malicious activity, also bots. Cloud infrastructure, this is very common. There are a lot of cloud companies that offer you virtual machines. You can host whatever you want there and use it. A lot of bots, it's very cheap. A lot of bots just purchase this kind of virtual machines, host their bots in these virtual machines, and go to the internet with this using those machines. It's very, very common. Okay, let's say a bot tries to mask his identity. He doesn't want you to know who he is, so he tries to imitate a regular browser user agent. Some succeed, but we see that some do some quirks, some mistakes, and I will show you here some common mistakes that we see. First of all, you see this user agent, okay? When the developer assigned the user agent in the variable, he writes down user agent. So we see a lot of user agent that starts with the text user agent. This can be a browser, it's not a regular Chrome, it's possibly something this is a bot. We don't know yet what he's doing, but we can see it's a bot. It's a very, very weird signature. Another type of signatures, we can see that, let's say a bot, when he enters the user agent, he surrounds the user agent with quotes or double quotes. No browser does that, okay? So it's a mistake, and we can detect those kind of mistakes. It's a very common mistake, by the way. Very common mistake, by the way. Look at this user agent, okay? It seems normal, everything looks good, but look at the Chrome version, okay? It's not an existing version. It's a mistake that's also been done by bots, okay? It's not an existing version. Maybe somebody played with the build of Chrome, but there's no official Chrome with this version, so we can detect that this is a very unique version. It's not something that exists in our traffic, so it's also an indication for bot. You have also HTTP request header quirks, not only with user agent. Small number of headers. If we see some request, we're only using host connection and user agent. Okay, it's weird. It's not a browser. Check out this one. Okay, it's mistyped, misspelled. Those kind of typos are very, very common. He replaced the letter EMP. Sorry. So actually we have a great rule to detect typos in common header names. It's also a quirk. Duplicate header names. When a developer builds the browser, he puts there a duplicate header name. This is also weird, and it also can be used by bots. If he's using HTTP 1.0 or lower, okay, no browser now uses this protocol. Only bots that use some development framework that is still using this protocol. Connection close, as we saw in the first example. Okay, most browsers will go with connection keep alive. Why would the browser open connection just for this certain request? So this is another way, those quirks. Okay, we said we ask the bot, who are you? What if the bots say, okay, I am this and this, but he's not really who he's saying he is, okay? We see a lot of search engine impersonators, a bot that comes with the user agent of a known search engine like Google or Bing, and it depends on the website that whitelists this user agent, but it's not really him. So we have a way we can detect where is he coming from. If he's not coming from Google servers or Google IPs or Bing IPs, then he's probably an impersonator. And we have a lot of those. Actually, this is a topic for a different presentation, but we see a lot of those impersonators. Okay, that was the section about signature HTTP transactional-based detection. I want to show you what our approach for behavior profiling. How do we profile a bot? First of all, we need to look on the overall activity of this website, okay? We do analysis for 6 to 12 hours traffic because there are a lot of bots out there that work in a very, very low rate in a very, very wide time span, so they won't get detected. So we need to make a little bit bigger time span, 6 to 12 hours, to detect all those bad bots. First of all, we can detect an IP, how long it's been active on a site, okay? If we see an IP that has been active on a site like 7 hours in a row, so okay, this is something weird. We're not saying it's a bot yet, but we detect this is something weird. How many different resources he requested? Here, if he requested the same page, but changed the query, only the query. If he requested the same host, but he used different paths, multiple paths. We can see if we can detect regular patterns over time. Maybe we can see the bot that he have a fixed time interval between each request, or maybe he have a certain workflow that he works with that is different from a regular browser user. So it's also a way to detect if he's a bot. For the targeted resources, if he's using the same page, multiple queries, let's see if he's looping through a parameter. Maybe he's only changing one parameter value. In this example, he changed the product's ID. He enumerates through the product ID and he changed the value over there. If he's using the same host and multiple paths, maybe he's looping through path file names like this. The folder is product, and it's changing the file name, which is in this case product ID, like the example I showed you at the beginning of the presentation. This is a very good way to detect this, because a lot of bots go to certain resource and certain catalog and scrape data from there. Website response code ratio. When a normal user browses a website, he uses his browser. Okay, so he clicks links he sees on the browser, search results. So you would expect that he will normally see the response that he's getting from the website. It will be okay responses, 200 responses, maybe redirection. But you don't expect him to see a lot of not found or unauthorized. A bot, on the other hand, can come with a pre-prepared URL list, or maybe he's enumerating through values, query values like we saw. Or even he's crawling the website and he's also going to hidden links in the HTML. So we expect that we see the ratio between the good responses to the okay responses to the bad responses will be bigger with bots, as therefore regular human users. This is a very good way to detect them. Another good heuristic. Workflow, okay? Does the IP follow a legitimate user workflow? When a user goes to a website and he wants to search for the catalog. So first of all, he goes to the home page, and then he goes to the search page. If you want to go to the shopping cart, first of all, he needs to go to the add product page. Also, a lot of websites, when you search the catalog, they implement autocomplete. So when you search the catalog and you start clicking the search terms, you will get autocomplete. So a normal user, if he wants to activate search, he will go through a lot of autocomplete pages. While a bot will not do all that. He will go directly to the search page. You won't see any home page. You won't see any autocomplete requests. Also, we'll go directly to the shopping cart. You won't see him go through add product. So this is another way to detect a workflow, a suspicious workflow. What about botnets? Okay, now till now I only speak on a resolution of a single IP. What if this bot is using multiple IPs? Is doing a distributed scraping bot activity, like the example I showed you in the first. So what we can do to detect those kind of distributed bot attacks, we can see if he's using one or more network by subnet or AS numbers. If we see a lot of IPs but they're coming from the same subnets, this is suspicious. We can also see if he's using the same set of user agents, okay? For all this activity, he used the same user agent or the same 2 user agents. Common HTTP request header signature, okay? If he's using the same weird common HTTP request headers, like we see the example, this is another indication. If he's requesting the same resource, all those IPs request the same resource. So this is a way for us to detect botnets. Actually, this is the most common activity methods of all those bots. They use distributed activity. They go through cloud providers, proxy, and they change the IP while active on the websites. So this is very, very meaningful, very, very significant for us to detect those. Okay, that was the detection. Now what I want to do is talk with you about mitigation and management. Okay, so we detected he's a bot, we know he's a bot. What should we do now? Do you think we should stop bots? We don't want to see bots in the webs at all? Okay, let's first of all say some stuff about bots. First of all, it's not a security problem per se, okay? All those crawlers, scrapers, it's more of a lost revenue, it's a business problem. When you crawl to a site and you buy all these products and resell it, or when you go to a site and you try to detect its prices so you can lower down your prices. It's not security, it's business. So it's not malicious. Not all bots are necessarily bad, okay? You have some good bots. Let's say you have a search engine. You don't want to block a search engine, you don't want to stop a search engine. Because if you stop a search engine, it's bad for you. You want to be ranked high in every search engine. You don't want to stop them. What about price comparisons? Okay, you have a lot of price comparisons that go to, from the same business segment, go to different websites, and they compare prices. So, and if you have the lower price, you will see it in this price comparison website. So you don't want to miss this bot. You want him to go to your website and collect this data because it's good for your business. So you don't want him to stop him. Another thing, if you stop bot, he will always come back, okay? You stop him, he will come back, but it will be much more sophisticated, so it's be much more harder to detect him, okay? Harder to detect, you need to find some more signatures, more different behavioral, maybe more challenges, so he will always come back and will come back bigger and stronger. So you don't necessarily want to stop bots. What you want to do with bots is, our approach is management. You want to manage the bots, okay? So let's say a website administrator, he knows what bots comes to his website, and he can tell what he wants to do with each bot. He can say, okay, this bot, I will give him full access because he's a good bot, he's a search engine, I want him to crawl my site, okay? If it is a little bit aggressive bot, he can slow him down. He can slow him down by serving him slow or even give him captchas. The slow down method is a very good method because you need to slow him down to reach a certain balance when it is not hurting your business, it's not harmful for you. You slow him down this rate, but still the scraper will continue to scrape or crawl your website at the same method. And it will not change itself, and and everybody's happy with it. The bot and the website administrator. You can, if it's a very big bot, you can serve stale objects. You can give him fake objects, fake HTML pages. It is a very good way. You can also limit his time activity. You can say, okay, I want him to be active only by night, not by day. So this is our main approach. We want to do some interaction between the bots and the websites so they can manage them. So you don't want to stop them. This is not our method. Okay, what I did till now is showing you all the detection methods and mitigation. So let's summarize what we saw. First of all, as we saw, a large portion of the websites is traffic generated by automated bots, okay? We saw the statistics, about 10% of all activity that we see is from web bots. Okay, we saw we can detect bots by their signature, okay? It is a good way. This is, like we say, the low-hanging fruit to detect bots. But if you want to detect a real big bot, you want to detect the whole phenomena, you have to have some sort of behavior profiling. You have to detect the distributed bots. So without that, you don't have nothing. Signatures is good, but it's not good enough. You need to add the added value of behavior profiling and botnet detection. As we say, it's not a security problem per se, okay? But it is a business loss revenue. Also, we are saying that attempting to stop bots will only make things worse, okay? We don't want to stop them, as we said before. We want to manage bots, no mitigation. We don't want to deny them at all. Maybe if they are malicious, very malicious, but not the malicious ones, we don't want to stop them at all. Okay, so basically this is my presentation. I say I still have some time. But the problem with bots is, okay, it's a new field now. It's not security, and you don't really know what is, while in malicious, in a web attack, you know what is happening, you know what he's doing. Here you're only seeing requests for pages, nothing too suspicious. So it's always a problem what to do there with bots. So this is our main challenge, how to detect them, not to detect too many false positives, to lower down the false positive rates. And all our detection methods that we presented here are very, very good and very, very helpful to us. And we don't have any product yet, it's still in research. But this is our research, and okay. I hope that you enjoyed hearing me. My English is not so well, but I hope I explained myself sufficiently. Okay, so that's it probably. If you have any question, you have a lot of time for questions now. Yes?
You said that you want to have bots to be active at night, but that basically means that you block them during the day, or what is your approach?
No, it's not my approach. It's a decision of the website. Maybe during daytime he has a lot of traffic and you don't want anything to be overloading in his bandwidth. So maybe you would like to do is, okay, tell this bot, you want to scrape my site. At night, I don't have a lot of traffic at night. come at night, not by daytime. This is a decision of the website administrator. It's not my decision. It's a business decision. Yes. We don't have any mechanism yet. It's still in research. This is what still in thinking. But maybe you can do some agreement with them not to be active by day, only active by night. Maybe you can serve them maybe to slow them down, very slow them down at so they will be active at a very slow rate. So only by night you can give them full access. You have a lot of methods, but this is our main approach. Further questions? Yes. There's no you mean a legal action? Me as a CDN, as a website administrator?
Yeah, you said like a cease and desist order. I mean, is there some investigation to try and find out who is calling the site?
We do some investigation to find out who's calling the site. Most of the time, even the website administrator can help us. He can say who is interested in his data. There are till now, there's still no product, nothing. It's just research. So we haven't thought about any legal actions that we can do for those bots. Another question? Okay, so thank you very much.